Hi everybody, this is your ever loving JP sir welcoming you all to this wonderful physics class. Today in this session we are going to differentiate the series and the parallel circuiting with a numerical so that we can understand the concept in a better way. Let us all combine together and enjoy learning. Let us get into the class. Let us connect here three resistances in series in this circuit. So, let it be first resistance, the second resistance and the third resistance, which are connected in series now to each other. I am closing the circuit so that there will be a current flow in the circuit. The current I flows in the circuit, and this is the terminal where we are giving the voltage here. Let me supply some 24 volt to this circuit. Also here let us take this as some 2 ohm resistance connected here, 4 ohm resistance and 6 ohm resistance respectively. Let us consider this as separate appliances connected in the series circuit. Here now in this circuit we can calculate the current whatever is flowing in the circuit. If we apply the formula for the effective resistance of this circuit for the series circuit, we know that Rs is the effective resistance of the circuit, that is equal to 2 plus 4 plus 6, which is equal to 12 ohm. The total resistance of this series circuit is 12 ohm. And we can find the current value from Ohm's law. If we apply Ohm's law, we know that V is equal to I into R, or I can write that I is equal to V by R. That is, I is equal to V divided by the effective resistance, that is Rs, where V is 24 volt and the effective resistance is 12 ohm. So, where I will get the answer as 2 ampere. Now, the current whatever flows in the circuit is 2 ampere. This 2 ampere current will flow in this resistor, in this resistor, in this resistor, and come out here as the 2 ampere current. So, that means in the circuit same current flows, same current is flowing, same current flow in the circuit like this. Then what about the voltage here? What about the voltage? How much volt out of this 24 volt, how much volt will go here? That is what we are going to find. That means let us consider all these things as the voltage here is V1, let the voltage here be V2 and let the voltage here be V3. And to find the individual voltages, we can write the formula like this: V is equal to V1 plus V2 plus V3. So, this 24 volt whatever we are giving is splitting into the 3 part to each of these resistances. So, that means I can write here that is equal to, applying the Ohm's law formula, the current, since it is flowing the same current, I can write I into the resistance here is R1 plus The same current flows here also, so I can put I, and the resistance is R2 plus the same current flows here also, so I can put I into R3. So that is equal to I here enters is 2 and the resistance is 2 plus the current entering here is 2 into the resistance is 4 plus the current entering here is 2 and the resistance is 6. So that means the voltage now becomes 4, here 4 volt will go out of the 24, 4 volt will go here plus 8 and 8 volt will go here, 8 volt will go here plus 12, that means 12 volt will go here. See now, out of the 24 volt, the voltage is splitting. The current is going the same, whereas the voltage splits. So 4 volt will go here, 8 volt will go here and 12 volt will go here. So if we add 20 plus 24 volt is the total voltage. So the total voltage what we are supplying to the circuit is 24 volt. The 24 volt only is splitting up into 3. How much voltage is needed for this appliance? It is taking. How much voltage is needed for this appliance? It takes that much voltage. How much voltage is needed for this appliance? This appliance takes according to the resistance what it has. According to the resistance of the appliance, the voltage is splitted in the series circuit. The same way, let us now consider the parallel circuit where I am connecting the resistances in parallel to each other. Now the 3 resistances are connected parallel, circuit is closed. Now let me take here the same 2 ohm I am taking, 2 ohm resistance, here 4 ohm resistance and here 6 ohm resistance. So this is the voltage supplying 24 volt and the current whatever goes here. So this current will be splitting here, here and here. The current will be splitting over here. But here voltage is splitting, whereas in the parallel circuit the current is splitting. Now let us take this current as I1, this current as I2 and this current as I3. And in this parallel circuit, voltage same, voltage remains same. That means the same voltage will go to all the appliance. Here also 24 volt will go, here also 24 volt will go and here also 24 volt will go. So the resistance takes, or the appliance whatever we have connected in parallel will take the same voltage. Then what about the current? That we are going to find. So and we know the formula. Let us find the effective resistance before for this particular circuit. We can apply the formula 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is equal to 1 by 2 plus 1 by 4 plus 1 by 6. Taking the LCM as 12, here all will go in 12. So 2 into 6, 12. That means 6 into 1, 6 plus 4 into 3 is 12. That means 3 into 1 is 3 plus 6 into 2 is 12. That means 2 into 1 is 2, which comes as here 11 by 12. Therefore, I can make this, this is 1 by Rp. So therefore, Rp is equal to 12 by 11. Now let us find the current what flows here in the circuit. The current here flows for the whole circuit, let us find. That is I in the circuit is equal to the voltage given divided by the Rp total resistance. Here the voltage is 24 and Rp is 12 by 11. That is 24 into 11 by 12, which goes 2 times here. So it is 22 ampere flows here. Here the current flowing is 2 ampere for all the resistances, whereas the current whatever is flowing here is around some 22 ampere. Now 22 ampere of current is flowing in the circuit. Let us find what is I1 and I2 and I3 in the circuit. That means the total current I is equal to splitting into 3. So I1 plus I2 plus I3, where I1 is equal to, where we can write this I1 as V divided by R1, because voltage, the 24 volt only is going in this circuit. So V divided by R1 plus the same voltage by R2 plus the same voltage by R3. Here the voltage whatever goes is same, and let us take now it is the voltage is 24 divided by R1 is 2 ohm plus the voltage is 24 divided by R2 is 4 ohm plus the voltage is 24 divided by R3 is 6 ohm. So where we get some 12 here plus 8 here plus 4 here. So 12 plus 8 plus 4, the current I is equal to 20 plus 24. Here 6. So 6, that means it is 22 ampere. The total current is 22 ampere, but for I1 it is 12. So the current going here is 12 ampere. For I2 the current going is 6 ampere, and for I3 the current going is just 4 ampere. Now if we compare this circuit, we can come to know that here it is 2 ohm, less resistance but more current goes. When the resistance is 2 ohm, the current supplied to the appliance is 12 ampere. And when the resistance is 4 ohm, the current supplied is 6 ampere. And when the resistance is 6 ohm, the current supplied is 4 ampere. See now in this 3 comparisons, when the resistance is low, more current flows in the circuit. So we can come to a conclusion that when we are connecting the appliances in parallel, it is proved that whichever appliance is having less resistance will get more current. That means if we are connecting some 3 bulbs here for our understanding, 100 watts, 60 watts and 40 watts like that, definitely the 100 watts bulb will get more current. That means it glows brighter because its resistance will be less. So whichever appliance is having less resistance will drag more current. I hope that in this session you all might have enjoyed the session and could have understood what the difference between the series and the parallel circuit. So let us meet again in the next class with another concept. Thank you.